A specimen of steel 28 mm diameter with a gauge length of 220 mm is tested to destruction. Tested to destruction means here we performed tensile test on steel specimen. Given steel specimen, okay. So ఇక్కడ మనం tensile test చేసాం. దాని మీనింగ్ అది tested to destruction అంటే అది మీనింగ్ ఇక్కడ, okay. So here we perform tensile test, okay. It has an extension of 0.16 mm under a load of 85 kilonewton. So under a load of 85 kilonewton, extension is 0.16 mm and the load at elastic limit is 165 kilonewton. The maximum load is 180 kilonewton. Here maximum load is also known as ultimate load. Here ultimate load is 180 kilonewtons. The total extension at fracture. So at the end of tensile test, this specimen is destroyed. Okay, na? So destroy in a specimen, fracture in a specimen, extension is your total extension. So total extension is given 58 mm. And the diameter at neck is 19 mm. Find the first question, stress at elastic limit. First we need to find the stress at elastic limit. And second question, Young's modulus of the specimen. What is the Young's modulus of the specimen? And third question, percentage of elongation. And percentage of reduction in area. And finally, ultimate tensile stress. Okay. So I given 5 questions, 5 parts. This entire question divided into 5 parts. So first stress at elastic limit and Young's modulus, and third question percentage of elongation, and fourth one percentage of reduction in area, at last ultimate tensile stress. First of all, let us understand this question. Here given a steel specimen and we conducted a tensile test and up to destruction, I mean up to the failure or fracture, we performed a tensile test on steel specimen and given some data. So first of all, let us list out the data. Mottam data emi ichadu, given data anta kuda first raddam. Then we can find values of the given questions. So first of all, given data. First given diameter of the specimen. Diameter of the specimen. Diameter of the specimen. So diameter small d is equal to 28 mm. Next, gauge length. Gauge length means original length. Gauge length or original length. Original length of the specimen. Length of the specimen before conducting tensile test. Original length. So L is equal to capital L, denoted by capital L is equal to, given how much? 220 mm. Gauge length or original length of the specimen 220 mm. Given dimensions of the specimen. Next, extension of 0.16 under a load of 80 kilonewton. Extension. This data is very important. Extension of the specimen. Extension of the specimen under a load of 85 kilonewton. Okay, na? So denoted by delta L is equal to 0.16 mm. So extension under a load of 85 kilonewton is 0.16 mm. See, this data is helpful to find Young's modulus. Okay, na? At the time of while finding Young's modulus, we have to use this data. So extension of the specimen under a load of 85 kilonewton is 0.16 mm. So Young's modulus find out చేసినప్పుడు ఇది మనకు యూజ్ అవుతుంది. Okay, next, load at elastic limit is Okay, so load at elastic limit. So PE means load at elastic limit. You given 165 kilonewton. 165 kilonewton. So, and this value is useful in finding stress at elastic limit. So stress at elastic limit find out చేసినప్పుడు ఈ డేటా మనకి యూజ్ అవుతుంది. ఓకే, నెక్స్ట్ maximum load. Maximum load is also known as, in tensile test, maximum load is also known as ultimate load. Maximum load or ultimate load. Maximum load or ultimate load. So denoted by PU is equal to 180 kilonewtons. Okay, maximum load or ultimate load is equal to 180 kilonewtons. And next given total extension. Total extension at a fracture. Okay na, at a fracture or failure of the specimen. Total extension at fracture, delta L total. Delta L total means total extension at a fracture. So how much? Total extension at fracture 58 mm. 58 mm. And also given neck diameter at fracture. Neck diameter dn, let us say dn. Okay, neck diameter dn, d suffix n means neck diameter 19 mm. Okay, so this is the given data. మొత్తం ఇచ్చిన డేటా ఇది. Using this data we have to find 5 questions. Okay, so first question, we need to find stress at elastic limit. Question number 1, stress at elastic limit. Okay, stress at elastic limit denoted by sigma E. Sigma E means stress at elastic limit is equal to PE by A. So PE means, okay na, P suffix E means, PE means elastic load. PE means elastic load by A means area. So elastic load, how much given? Given 165 kilonewton. So let us convert kilonewton into newton. So kilo means 10 cube. So 165 into 10 cube newtons. Okay na? This is PE. Next, what is A? Cross sectional area of the specimen. Original cross sectional area of the specimen. Okay na? So generally cross section of the specimens are, tensile test specimens are circular. Okay na? సో ఎక్కువగా కూడా మనం ఏం చేస్తామంటే సర్క్యులర్ స్పెసిమెన్స్ యూజ్ చేస్తాం. అవి స్టాండర్డ్స్, అవి సర్క్యులర్ అండ్ రెక్టాంగులర్ సమ్ టైమ్స్. సో మోస్ట్లీ ఎక్కువ యూజ్ చేసేవి ఏంటంటే ఇన్ జనరల్ క్రాస్ సెక్షన్ ఆఫ్ ది టెన్సైల్ టెస్ట్ స్పెసిమెన్స్ ఆర్ సర్క్యులర్. సో ఆ సర్క్యులర్ స్పెసిమెన్, ఐ మీన్ సర్కిల్ అయితే ఏమవుతుంది, వాట్ ఈస్ ద ఏరియా ఆఫ్ సర్కిల్? ఏరియా ఆఫ్ ద సర్కిల్ ఈజ్ π/4 into d square. π/4 into d square. Area of circle is π/4 into d square. Now π/4 into diameter of the specimen, how much given? 28 mm. So 28 whole square. Now sigma E is equal to PE. PE means 165 into 10 cube by 165 into 10 cube by area π/4 into 28 square. π/4 into 28 whole square. Sigma E is equal to reciprocal of π/4, 4/5. So 4 into 165 into 10 cube by pi into 28 whole square means how much? 784. 28 whole square 784. So find this value using scientific calculator. Let us find this value. If you calculate, you will get approximately sigma is equal to, here I got 267.96 Newton per unit, Newton per mm square. So this is stress at elastic limit. Okay, so దీన్ని calculate చేస్తే మనకి value వస్తుంది. What about second question? Young's modulus, very important. Young's modulus. or modulus of elasticity. Young's modulus is also known as modulus of elasticity. Young's modulus denoted by capital E. And according to Hooke's law, what is the formula for Young's modulus? Young's modulus is equals to stress by strain. Stress by strain. Again, stress denoted by sigma, strain denoted by epsilon. So to find Young's modulus, so in the given data we have extension under a load of 85 kilonewton is 0.16 mm. We have to use that data. So anyhow here sigma means stress. Stress is equal to what? Load by area. Stress is equal to load by area or resistance force by area. So next, epsilon means strain. Strain means in case of tensile test. So this is strain here. This is longitudinal strain, normal strain. So here epsilon means longitudinal strain. So change in length by original length. Change in length by original length, or extension under a load of 85 kilonewton by original length. Okay. So extension under load of 85 kilonewton, how much? 0.16 mm. So here delta L is 0.16 mm. Next, ikkada P and enti load. So how much load? We applied 85 kilonewton. 85 kilonewton. We observed this extension under a load of 85 kilonewton. Therefore, P is equal to 85 kilonewton. Convert kilonewton into newton. Appudu emotundi 85 into 10 cube newton. Still any unknown? Here L means length of the specimen. How much? 225 mm. Original length of the specimen, gauge length 220 mm. Okay. So cross sectional area, we know that pi by 4 into d square. Okay. Just substitute all the values. Then Young's modulus. First of all, Young's modulus E is equal to stress means. Here stress means load by area by strain, change in length by longitudinal strain, change in length by original length. Okay, na? Reciprocal of delta L by L, L by delta L. So simplification of this expression will be P L by A into delta L. PL by A into delta L. So P into L by, or we can write P into L by A into delta L. Let us substitute all the values in this formula. Then we can find Young's modulus E. Now Young's modulus E is equal to P. P means load. So here load is 85 into 10 cube. Okay. Into L, gauge length 220 by area of specimen pi by 4 into d square, pi by 4 into d square into L. Delta L means change in length or extension. So extension 0.16. So extension under 85 kilonewtons is 0.16. Now E is equal to reciprocal of pi by 4, 4 by 5. So 4 into 85 into 10 cube into 220 by pi into diameter of the specimen 28. So 28 square whole square into 0.16. So E is equal to, so if you multiply 4 into 85 and 10 cube and 220, you will get 7. Here I got 7, 4, 8, 0, 0, 0. So and denominator value 394.08 approximately. So now E is equal to, if you calculate, you will get final answer Young's modulus 189,808 Newton per mm square, approximately 189,808 Newton per mm square. So if you write in kilonewton per mm square means 189.808, or you can consider 190. You can take 190 kilonewton per mm square. Okay. So kilo means 10 cube. We have to move decimal point. How many places? 3 places. 1, 2, 3. So 189.808, or approximately we can say that 190 kilonewton per mm square. Young's modulus approximately equal to 190 kilonewton per mm square. This is second question answer. సో యంగ్స్ మాడ్యులస్ ఎంత వచ్చింది మనకి 190 kN/mm². నెక్స్ట్ థర్డ్ క్వశ్చన్ పర్సంటేజ్ ఆఫ్ ఎలాంగేషన్. క్వశ్చన్ నెంబర్ 3 we need percentage of elongation. Percentage of elongation. Percentage of elongation. So what is the formula for percentage of elongation? Percentage of elongation is equal to final length of the specimen minus original length or gauge length by gauge length. So this is one formula to find the percentage of elongation into 100. Okay. So percentage of elongation is equal to final length minus gauge length by gauge length into 100. So it's like LF minus LG by LG. Final length minus initial length or gauge length by gauge length into 100. This is one formula. Suppose, but here in this question he didn't mention anything about final length, but he given total extension at fracture. Okay, total length of the total extension of the specimen at fracture is given. So or we have one more formula for percentage of elongation is equal to total extension at fracture by gauge length or original length into 100. Okay, na? So based on given data we have to use either this formula or this formula. Okay, if final length is given we have to use this formula. Final question lo final length iste idi use cheyali, total extension at fracture iste idi use cheyali. Anyhow here given total extension at fracture we have to use this formula. Total extension at fracture delta L total, okay na, by gauge length L into 100. So total extension at fracture given 58 mm by original length 220 mm gauge length. Original length or gauge length both are same, mm. Okay, 58 by 220 into 100. 58 into 100 5800 by 220. So 0 cancel. If you calculate you will get how much percentage? 26.36%. So percentage of elongation is 26.36%. Next question, percentage of reduction in area. So fourth one, percentage of reduction in area. Percentage of reduction in area. So we have to find percentage of reduction area. So percentage of reduction in area. So what is the formula? Original area minus neck area original area minus neck neck area by original area into 100. Okay, so original area AO minus neck area AN by original area AO into 100. Here original area is equal to what? Original area, cross section area of the specimen, pi by 4 into d square. Neck area AN is equal to pi by 4 into, we consider neck area as dn, so dn square, pi by 4 into dn square. So replace all a0 and an here, replace expressions for a0 and an. So then pi by 4 into d square minus pi by 4 into dn square by original area pi by 4 into d square into 100. See, pi by 4 common. In denominator also we have pi by 4. If you take pi by 4 common, then pi by 4s get cancelled and you will get d square minus dn square by d square into 100. Now observe numerator. This is like a square minus b square. A square minus b square means a plus b into a minus b by d square into 100. So d how much? Diameter, original diameter specimen 28, and dn neck diameter how much you given? 19 mm. So 28 plus 19 into 28 minus 19, d minus dn by d square, 28 whole square into 100. 28 plus 19 how much? 47 into 28 minus 19, 9 by 28 whole square, 784 into 100. Okay, so if you calculate 47 nines are how much? 47 nines are 423, I think. So 423. So 423 by 784 into 100. So 423 into 100, 4,000. I mean 42,300. 42300 by 784. So if you calculate, you will get percentage of reduction areas 53.95 percentage. So final answer is 53.95 percentage. Okay. So for percentage of reduction area of the specimen is 53.95 percentage. Next, at last we have to find ultimate tensile stress. Okay. So last question, ultimate tensile stress. Question number 5. Ultimate tensile stress. So ultimate tensile stress denoted by sigma u. So sigma u is equal to ultimate tensile stress is equal to maximum load. Maximum load is also known as ultimate load. Maximum load by area. Maximum load by area. So sigma u is equal to maximum P maximum by area A, or PU by A. Ultimate load by area. So ultimate stress is equal to maximum load by area or ultimate load by area. Here he given how much ultimate load. So here he given 180 kilonewton ultimate load. 180 kilonewton by area. So 5 by 4 into d square unit mm square. Unit mm square. So 180 into kilo means 10 cube. So 180 into 10 cube. Okay, newtons by 5 by 4 reciprocal 4 by pi. Okay, so 4 into 180 into 10 cube newton by pi into diameter of the specimen 28 mm. So 28 square mm square. 4 into 180 720. So 720 into 10 cube by 28 whole square 784 into pi newton per mm square. So unit of ultimate stress. Okay, so sigma u is equal to, so this value will be 292.32 newton per mm. Therefore ultimate tensile stress is, okay, ultimate tensile stress is 292.32 newton per mm.